Good afternoon again, once more. You are all welcome to Jumbo Academy. This is an academy where we'll be looking at physics, that is energy and matter, relationship between energy and matter. We equally look at electrical engineering components, engineering devices, their applications, usages, both domestic and industrial. Then we'll look at calculus to know their various functions and equally their applications in a modern day industry. In today or in this class, we are going to look at electrical power. Electrical power. Electrical power. Then question we ask ourselves now is, what is electrical power? What is electrical power? Electrical power is defined in engineering as the rate of consumption of energy, the rate of consumption of energy, or the rate which energy is transferred or used or consumed. This defines an electrical power. We still have the mathematical definition of it, but before we go to the mathematical definition of it, it will be very paramount at this point to know that electrical power is measured in watts. We still have other units like the joule per second, but later on in this very particular class, we are going to know how we have the second unit as joule per second and the derivation from power equal to energy divided by time. We can still arrive how we now got the second unit as joule per second. So we have defined power as the rate of consumption of energy or energy used with time. So by a mathematical definition of power, we can now say that power is equal to IV. Power is equal to IV. That is, power is equal to current multiplied by time. Current multiplied by voltage, I mean to say. So what we are saying is that before you can use the mathematical definition of it, remember that the parameters, the terms there need to be identified. Let's say, for example, we are defining mathematically now. If we are defining mathematically and we are saying that P is equal to IV, this is a mathematical definition of power now. P is equal to IV. But you should know that this is not a proper definition of power mathematically, because you need to identify the terms there and the parameters. And what are the terms there? The terms there are, we have P, we have I, we have V. So if you don't define these parameters, somebody will think that P means prosperous or prosper or any other thing. Likewise, I might mean indigenous, illustrious, anything that can start or commence with I. Likewise, V can mean voluntary. It can mean voluminous. But by the time we define all these parameters, we are now putting a very precise and concise definition of electric power mathematically. Now, let's define now. We have P. We say where P is equal to power in watts. Either you say power in watts or you say power measured in watts. Then we have our I will mean current in ampere. So our V will be equal to voltage in volts or measured in volts. Remember, all the abbreviations are there to be used. We can still say in brackets W, meaning watts. Symbol for ampere, we have A. Symbol for volts, we have V. So you can see. And another thing we should know about current. Current is the rate of flow of electrical charge. The flow of electrical charge or the flow of electric charge defines current, and current is measured in ampere. And the instrument for measuring current is the ammeter. We still have other instruments, like we can still have the multimeters, and those instruments could equally be converted from one form to other to picture or to measure other values of variables. So, but ammeter will give you an appropriate or near to exact value, which you can now use to work on. Ammeter is okay for measuring current. Then we have the voltmeter, which is used to measure voltage. And of course, we have defined voltage as voltage is equal to the electrical difference between 2 points in an electrical circuit or in a conductor or metallic conductor. So, and the potential difference is measured in volts. So another thing we should know about power is that power varies directly with the current and with the voltage. What is the meaning of this? The meaning of this is that as current is increasing, power is increasing, or as voltage is increasing, power is equally increasing. So you can see what it means, and that is why we say that the power is measured in watt. And what is watt? Watt is defined as the rate or flow of 1 joule of energy per unit second. That defines 1 watt. Now, another thing that will be very, very important to know is that we have larger unit of power. And what are larger unit of power? Larger unit of power, we have one, the kilowatt, written as kW. And kilowatt is equal to 10 raised to power 3 watt, or 1000 watts. We still have the second larger unit of power, which is known as the megawatt, written as MW, and the value is 10 raised to power 6 watts, or 1 million watts. So these are the higher units or larger units of power. Then another thing we are going to look into is power classification. Classification of power. Classification of power or categories of power. Electric power is categorized depending on requirements and the choice of an individual, what he intended to do with it, or what he want to do use it for. Basically, we can put a 3 classification of electric power. One, by sources. And what are these sources? Sources like, is it direct current power, or is it AC current power or voltage power? So this is a sources aspect or category of power. Then another classification is by application. By application, is it reactive power unit? Is it active power unit? Is it apparent power unit? Of course, real power is the same thing with actual power, so it's still the same thing with active power. So these 3 things are like synonyms. All of them mean the same thing. So this kind of applications are used by clients or by people or individual, depending on what you need. That's why we say applications. So do you need reactive power? That is the inductive loads, the aspect of power that control inductive loads. Then do you need the actual power or the real power or the active power consumed by your devices or components? Then do you need the apparent power, which is the combination of both the active or real power